Good morning, good afternoon, or good evening, depending on where you are as we kick off this webinar today. Thank you for joining us at Penguin Solutions for today's webinar as part of our ongoing series on AI infrastructure, where today we're going to focus specifically on the topic of is your infrastructure production ready? And this is kind of a follow on to the webinar that we did just a few weeks ago, looking at design elements for your overall AI infrastructure deployment. My name is Mark Siemens. I'm part of our Penguin Solutions team, and I'll be walking you through the material today. So let's go ahead and dive in. In terms of the agenda for today, we're going to walk quickly through kind of just taking a look at, again, what is this AI infrastructure we're talking about, the purpose and the objectives of what we're trying to achieve here, also the challenges that we're looking to hit. But then we're going to move quickly into the discussion around this pre-production validation process that we want to take these systems through as we can kind of work through the completing of the build process and prepare ourselves for taking the system to production. So again, I hope you learned something from the material today. We're going to go through on kind of a rapid fire basis, covering a wide range of issues. I certainly learned some things even as I put materials together for the session today. So at the end, we will have a few minutes to take some Q&A. And so if there's a specific question that you have, there'll be opportunities for you to type that into the comments section as well. So as we think about AI factory infrastructure, and this picture on the right is actually not a stock photo, it's a real picture of an AI system that Penguin Solutions designed, built, and deployed in conjunction with one of our production customers. And in fact, this system extends far beyond what you see here, in fact, spanning two more data halls full of equipment. But as we look at what we're trying to do with this infrastructure, if we focus our attention on the left of the slide here, it really comes down to two halves of this environment. The top half is really what our customers are looking to achieve. These applications they're looking to run to perform high performance computing and AI training at scale, running applications like Jupyter Notebooks, TensorFlow, PyTorch on large data sets. And the infrastructure that we're talking about providing is this whole foundation on which those applications are going to ride, right? And so it's the data center infrastructure, thinking about power and cooling, and then the compute components, the data storage components, the networking, and then building our way up through the software layers to provide that rock solid foundation on which we can run those applications. And so as we think about the process we go through, is it's going to really come down to a couple of key halves, if you will, separated by a key moment in time. So the objective as we build these systems, for the first half of the process, it's really about designing our systems, getting that system to production readiness on time and on budget. And then where we're going to focus today is on achieving that moment where we make the decision that we're ready to go to production and take that system live. And then beyond that, we've got this whole process of smooth operations at scale. And so again, if you think back to the process that we use at Penguin as we work through this, typically it's characterized at this left half around a design, build, and deploy process. And at the conclusion or the culmination of deployment is making that call to go live. And then after that, we've got these ongoing processes we'll cover another day around system management, system expansion, and then the ongoing evolution of these environments. But where we're focused today is at the top, is at getting to that moment where we say we're ready to go. Obviously, all these pieces come into play, but we're going to drill in on that segment. For those of you who may have joined us for our previous webinar in the series, we talked through a bunch of issues that need to be taken into account, things ranging from power to networking design for these systems, and then moving forward to what's your plan for isolating performance issues and root causing issues that you may see cropping up either with failed nodes or even with just degraded performance. And you can see these were kind of 1, 2, 3 in a list of a number of issues that we brought up. But we're really going to focus today is drilling in on this fourth topic that we covered in that, which is this idea around achieving production readiness. And why do we want to put so much emphasis on this? Well, it's really around the idea of avoiding false starts as we bring a system to production. And as this slide talks about, nothing kills enthusiasm faster for this system than bringing something live that's either unstable or is not running at full performance for the users, right? It's this rocky road that can blow out your user confidence in the system. And so as we bring the system to production readiness, we're going to think about stability, performance, and then the potential impact of system outages and how we minimize that impact. So let's think about this. So this is actually a picture again of a real-world AI factory that Penguin constructed for one of our customers, and it's kind of looking down one row of AI GPU-based nodes, DGX nodes in this case, within a customer data center. And the reason I bring this picture up is to think about, well, what's the big deal about really making sure you're ready before you go to production? Well, what's going to happen the day you go live is that users are going to start submitting jobs to the scheduler, and those jobs are going to get allocated, as you see here, across some number of nodes in the cluster. Next job kind of comes along, more nodes get spread out through the cluster, and this is going to go until essentially the resources within your cluster are consumed. But the way that these jobs get allocated is that they're running for their own purpose. And what I mean by that is that they're unique into themselves in terms of the number of nodes they run, the complexity of the job they're running. And because of that, they've got their own duration that they're going to run, and their own sets of resources they're going to consume. And so the bottom line is, and there's going to be more jobs queued up at any given point. And so once this system goes live, there's never going to be a good time to be able to say, oh, we're going to stop all the jobs and quiesce the system to be able to do large scale maintenance. And so if you're not confident when you go live that you've got a strongly performing system, it's going to be a rocky road in terms of operating that system as you go forward. So it's important to get it right so that we avoid impact to user jobs and having to try and find that moment where we got to shut the system down again. So what do we do to get to production readiness? Well, it comes down, as this was one of the slides we used in our prior session, to two key areas. The left one here is network readiness, and we're going to drill into this today, why that's so important, maybe more important on these systems than almost any other sort of system you might deploy. And then the other one is cluster readiness in terms of the rest of it. Once you've got your network sorted, it's about getting strong nodes that are exhibiting strong characteristics running in a multi-node cluster type environment. And then, as you can see here, we'll drill into a process that we walk through, and in fact, a workflow to be able to build our way up to high confidence as we take this system live. So, and then make that decision to go live and get great results out of our system. So, if we start into the networking topic, which was that left square, and we kind of drill into this a little bit, at the very basics, it's about getting this system organized and translating your design of the network into the physical layout. And that involves things kind of even as shown here, accurate cable labeling. We have a whole process we go through in our factory as we're building out these systems for our customers around cable labeling, cable assignment, and then really getting these cables organized, cleaned up and dressed as these systems are getting built from a rack by rack basis as well. And then you take these well-organized racks and start building them up into pods of nodes and eventually into complete clusters. And so this is really going to be about making sure each one of these cables is correctly deployed and that you're going to be able to get the correct connection, because these are going to be tough to sort out later if this first piece is not organized and correct. And again, as I mentioned, we typically, as we go in and deliver systems, we'll start with rack by rack kind of pre-validated designs. And so this isn't necessarily a specific cluster we might deploy, and shown in the picture here. What these racks are essentially just examples of pre-designed configurations for different use cases, whether it's a two-node GPU-based rack on the left, a four-node GPU-based rack kind of shown next to it an RT2 or other things for networking racks or storage racks. But we do a lot of work up front to get the design correct, and then we can provide a recipe for the actual construction that takes place in the factory as these get translated into true systems. And these designs typically look something like this, where you've got, a complex network diagrams, a specification of the system and how it's all going to connect together, and then you can measure yourself against this design as you put the solution together. Now, if you look at the networking that goes on, this orange set of cables, because you see as we talk through this around having both Ethernet and InfiniBand networks on these NVIDIA-based GPU clusters. So the orange here represents the Ethernet, or what some people refer to as the front-end network. And this is the network that users can use to access the nodes in the cluster. It's often the network that storage connects on to be able to supply data to the GPU-based nodes. And then these purple lines that are shown a little bit further up would be the InfiniBand, or what people sometimes call the backend network, because this is really a private network that users really never see. It's specifically used by the GPUs to talk to each other, to turn many GPUs into a single contiguous, almost really one big GPU that's executing the workloads. So as we connect these things together, we can experience multiple problems that we're going to need to diagnose as we start to put the system together, do our testing. So one of those would be just physical link testing, right? It's actually running tests to actually see, are things linked the way that we thought they were going to be linked in the design that we had. And so you can use standard networking tools and scripts to be able to pull that data from the configuration. And in the case where you're not seeing links established the way that you might think they would be, it's now for you to drill in and kind of identify which links are those, and try and sort out, is this a port mapped issue where things are cross-wired? Are these a problem where a network interface card might be down? Is it a problem with an optical transceiver? Because a lot of the networking that goes on, because of the size of these systems, is optically cabled. So there could be an optical transceiver problem, or perhaps even a cable issue. So it's really getting in and tracking these things down at a physical link perspective as the starting point. The other thing that's interesting is you may not have a link broken in terms of things showing up as dead, but you may be experiencing degraded performance on a particular link. And if you're using optical cabling, one of the things to look at literally is just the cable ends, the optical glass ends on the cables being dirty. This picture was one that I pulled from a set of examples where you can see, as this kind of is looked under a microscope, right? All this gunk that's on this particular piece of glass that would be at the end of the cable, and it's going to impact the transmission of light across that cable, and it's going to, in the end, impact performance. And so one of the things you'll need to look at is, do I have degraded performance, and could it be optical cable based? And in most cases, you're going to get familiar with using data center tools like this one, which is an optical cable cleaner, to be able to ensure that these are clean and going to be delivering full performance. Again, with these systems, everything matters, every single step, in terms of being able to squeeze out the correct performance. The next level up, though, once we've got it physically working, is really looking at routing protocol and availability testing on the network. And there are tools you can use, Ethernet tools, SNMP based tools, to be able to interrogate the network and make sure all the different components are up. In InfiniBand, there's a command called IBdiagnet that you can run, which will go out to the entire network and pull back all kinds of information about the configuration of your InfiniBand, that back end network. And you can, again, write scripts to map that against the physical delivery of what's there versus the design that you started with, to make sure everything is mapped and operating accordingly. And again, the reason that this gets to be complicated is you very quickly, because each one of these AI nodes is going to have up to 10 network connections per node. And you have many of these nodes connected to a complex networking infrastructure. And you can quickly evolve to the point where 10 cables turns into 100 cables, turns into 1,000 or 2,000. The cluster that I showed in the picture earlier had 40,000 network links. And so it's easy to get a few things wrong that can impact your readiness for production and performance. So once we get past the routing protocol, again, we start working our way up to higher levels of the stack, and this is where we'd run commands for things like latency testing, throughput testing. Are we getting dropped packets on the network? Because these are the things that are the silent death in terms of both the reliability of the cluster and your ongoing performance. And one additional one I wanted to highlight, it's something that we've seen over time in large deployments, is a condition called link flapping. This is can drive you crazy. But what link flapping is shown kind of here on the slide, it's a communications uh, syndrome, I guess, where a particular link doesn't mean all links, but you can have it where one particular link in your environment is literally flapping. It's going online, offline, and unpredictably, right? And so you'll get a dropped connection, but then by the time you'll go to look, that connection may have come back online. Now sometimes link flaps happen because a node gets reset, and you'll see evidence of that in a log where a node got reset, and it'll show that, oh, this went offline and then it came back on. And those certainly aren't problems, especially if it's because you're rebooting a node, maybe as part of a repair effort to bring something back. But it's the cases where you aren't rebooting nodes, where perhaps you've got a flaky network interface card in your configuration. It'll be about tracking those down and looking for evidence of that in the logs where you may have had that going, and kind of squeezing all that out before you go to run production, because that's the kind of thing that will cause jobs to fail and will drive your users crazy, because all the GPUs in the job need to be communicating in order for that successful outcome. So once we've got the network going, which is kind of that left box we talked about, right? Make sure the network's right, and all these things are building up to that. The next thing that we're going to do is provisioning the nodes themselves, both from assuring that the nodes are strong, they're healthy, they're robust, they're burned in the configuration, and then building those nodes up in what we call an accumulation process to take 2 nodes to make 4 nodes to make 16 nodes to make 32 nodes, and building up this larger and larger AI cluster, and all along the way validating the strength of the configuration. So if you kind of drill into this workflow, the first thing that we would do is to validate our ability to automatically provision nodes. So using our cluster management software, that we've got the software bundles ready to go, that at any given time we can take any node in the cluster and we can reliably image it and reboot it and bring it into cleanly into the cluster. The next phase is running that under duress, under stress, right? And making sure that the GPUs are healthy, all the memory is healthy, the network interfaces are consistent and strong. And then again, we go through this process of doing accumulation testing as the third piece of that workflow, where now we start running workloads small at the beginning and building our way up as we go to pull the entire system together. So this kind of step-by-step process is building your confidence and your strength in the system beyond the network now, to where you're actually looking at the health of the node itself under duress and over time, to make sure that you're not going to have any mortality as you take your system live. The other thing that you'll be wanting to do, and if you've worked with these AI clusters, this will be a familiar term to you. And if you haven't, you'll become familiar with this over time. But it's this, what's called this term NCCL, it's pronounced nickel. And you'll hear people talk about nickel testing. What are the results of your nickel test if you're trying to bring something live? And this stands for the NVIDIA Collective Communications Library. And it is, in fact, that software layer. If we take this picture on the right of the network diagram, nickel testing is typically looking at, if we drill in, this interconnected web of GPUs, right? And this ability to take individual GPUs and stitch them together into an integrated, highly connected, low latency cluster. And so we can forget for a little bit about the Ethernet part of this at the bottom. And what we're really looking for is, do we have consistent performance and all the way across very balanced performance as these operations take place? You'll hear this term all reduce in this case. And what all reduce refers to is the characteristic of these workloads, that they are all really operating on a collective basis where each GPU does a unit of work, and then they all share their information about what happened, and then they do the next unit of work. And it's this lockstep that requires all the network to be operating at kind of a very balanced level. And nickel testing is the thing that will pop out and tell you if you've achieved high quality status. And then finally, I put this slide on. The last thing you're going to do, or one of the last things before taking your system to production, you got a lot of confidence at this point, is to run representative workloads. Maybe you're going to pick some target users who are going to be some of your initial go live users. You'll take their data sets, you'll take their workloads in a pre-production basis, and you're going to start running these and monitoring them very closely within your environment. And this is really where you're going to eke out the confidence in the rest of the system. Things like storage systems, the job scheduler configuration, the end-to-end execution of the workloads, checking for things like clean exit status as these jobs run. And maybe you run a job that runs over 200 nodes. As that completes, what you want to make sure is that it completes cleanly, and that those nodes, as they get prepared for the next job, don't have any leftover processes, don't have any kind of junk still out there from the prior job, and that you've got a healthy system that, as it goes from job to job, is going to deliver consistent performance. So once you've done this, you're just about ready. The one other area I wanted to touch on is this idea of spares. Nodes are going to fail. That's just the reality of operating these systems at scale. These are complex machines with, in many cases, 8 GPUs, 2 CPUs, a lot of memory, many network interface cards. So the reality of operating these systems at scale is that it's a game not of hoping things don't fail, but of just anticipating that they're going to fail and being ready to rapidly address that. So the one other area we spend time as we're looking to take a system to production is looking at the domain of systems that we have, looking at the failure points, coming up with some anticipated failure rates for different components, things like NVMe drives and memory DIMMs or GPUs themselves, and building up at the site a cache of spares designed to be able to rapidly repair nodes that may fall out. And so we want to avoid is, the failure of a node, and then where we take that offline and start a multi-day or multi-week process of diagnosing it and then waiting for parts to be able to get that node back and get it back into production. These are extremely expensive systems, and so every one is precious. Every one of these nodes is precious in a configuration, and so having all the potential parts you need at the site can allow your team at the data center to quickly triage problems, repair a node, and then re-provision that back into the cluster to get back to full strength. The other thing we do is we do track failures and report on those pretty regularly, just to look, are there any trends within the domain that we're operating in that may require kind of further attention. But once you've got that done, you've done all this testing, you've got your spares ready, people are trained, you've run representative workloads. At that point, I think from our perspective, working with customers, we'd say, let's go. It's time to take this thing to production, and we've done everything we can to feel like this thing is going to be a solid operating environment that is going to deliver great results for the great results and output for the users. So hopefully some of the things in there were helpful as we look through the process. What we want to summarize, I think the top statement here: great production AI outcomes follow thorough pre-production validation. Right. This is the ounce of prevention is more powerful than a pound of cure. It's by the time you get to production, if you've done these things, you're going to feel great about your situation. Again, working through building up the networks to nodes, validating at a full cluster performance level, being ready in terms of rapidly responding to failed components with on-site spares, and then going live and obviously monitoring that environment, especially during those first few weeks of production. So with that, we're going to go ahead and flip over to Q&A, and I'm going to look here. It does look like we've got a couple of questions that were submitted. So here's one that's, is there a specific list of applications? Oh, when we talked about the software at the beginning, right? We had those apps at the top, and there were examples that were up there. Is there a specific set of applications that can be run? Absolutely not. I mean, there are applications far beyond. There are AI packages that are out there, and new ones that are showing up on the market. The infrastructure we're talking about is designed to be able to support a broad array of applications running on top. So whether it is the things we showed, TensorFlow and PyTorch, to things like ClearML, or a Run AI framework, or a weights and biases, or other tools that are out there in the marketplace. It's very flexible to be able to operate that on this same type of assured infrastructure. Then this next question was, it says, you briefly mentioned storage as an area to benchmark and validate as part of the readiness process. Are there specific storage platforms that users need to leverage, or is it a more flexible model? Yeah, that's a good question. We didn't delve specifically into storage as part of this session, but the architecture is absolutely designed to support a broad array of storage platforms. And as we work with customers, we implement typically Flash-based high performance parallel file system environments, but it can be from a wide range of vendors and providers. And so if you need a recommendation on that, that's something we could provide. Or if you've got a vendor that you work with in terms of your core storage environment, pretty typically that can be stitched into this environment. The one thing we're going to look at is it fast enough to be able to keep those GPUs fed so that you're not wasting cycles? And that would be the thing we would look at during that performance testing, is to make sure that the performance there is at the level that we want. Okay, with that, I think we're at time. And so I want to say thank you to the folks that helped us put this material together, and all of you who have tuned in, or if you're watching this later on a recorded session, hopefully there was something valuable that came out of that. If there are specific questions you'd like to work with Penguin on, you can see 2 QR codes on the screen here. One, if you've got a specific question you'd like to connect with a solution architect about, we do it all the time. You can click on that QR code, fill out a short form, and we'll set up a consultation for you with someone that works with these types of AI infrastructure. And then if you'd like a more broad look at how these systems come together, you can click on the QR code or scan the QR code on the right to be able to access and download a Penguin Solutions ebook on AI infrastructure. So again, thanks for your time and attention today. Be on the lookout for future webinars in this series, and we'll look forward to connecting with you on your AI-related projects. Thanks again.